All right, so last thing we're going to talk about is meso compounds. And so these guys are tricky. And so in meso compounds, you have two stereocenters, but no enantiomer. So if you think about the equation from kind of the last sections of video 2 up to the number of stereocenters, that's the max amount. Sometimes they can have less. The main thing all of these meso compounds will have is a plane of symmetry. And so if you can find a plane of symmetry somewhere, you can eliminate out some of these enantiomers. So let's take a look at this. Right, if we have a wedge for a methyl group and then another wedge for a methyl group, we can label both of these as R or S. And so if you do this correctly, this top one will be R, this bottom one will be S. And then if you're thinking about rotating or drawing the enantiomer of this, what you might draw is the cyclohexane, but now with both dashes, right? And if you figure out the stereochemistry here, this one is S and this one is R. So it does indeed look like they flip, right? This top one became an S and then this bottom one became an R. But really there's a plane of symmetry here. And so what happens if you rotate 180 degrees about this, you'll see that these molecules are actually the same, right? If you rotate 180 degrees, it's just that this one becomes this one. And so these two on the left and the right are the same molecule. These are not enantiomers of one another. They are mirror images, but they are superimposable. So it has two stereocenters, but it does not have an enantiomer. But you have to have this mirror of symmetry or this plane of symmetry in here. So for example, if you don't have the plane of symmetry, something like this compound and this compound are indeed actually stereoisomers of one another or enantiomers of one another. All right, this is R, S, S, R. And there's no plane of symmetry here, so you can't really split it in half. Another thing that you want to kind of keep out on the watch for these meso compounds is that they can be a little bit tricky, especially with non-cyclic alkanes. And that's because they can be given to you in an image like this. And so this doesn't look like it has any plane of symmetry. However, remember we can rotate about this bond. And when you do so, if we keep this one constant, we'll rotate this other one so that this methyl group is pointing down. And if you think about where the chlorine is going to be, it's going to be pointing up as well. And then there'll be dashes of hydrogens there. And so there's a plane of symmetry, right, bisecting this. And so this is a meso compound, and so it won't have an enantiomer. If you try to draw the enantiomer, you will end up with this, but these two are actually the same molecule. It's just that you've taken one of them and translated them in three-dimensional space, right? Basically, what you're going to do is you're going to take this whole molecule and rotate, about 180 degrees, right? And then this chlorine up here actually becomes this chlorine down here, and then this chlorine down here becomes this chlorine up here, and they end up being the same compound. So always keep an eye for these planes of symmetry because you may have a meso compound.